So we're now really getting somewhere in terms of our electrons, the orbitals, where they're located, and how that's going to really show some cool things about the periodic table, and then about how different elements can form bonds and get together with different things. So we've seen different orbitals, and so let me, hopefully here we go with this green here. We have orbitals, and we have our S, our P, our D, and our F. And I can't stress enough a couple of things about these. There is no difference between this S right here, that might be the 1S, and then something that might be the 4S, which would be the exact same thing, still a sphere, but just a bigger sphere. That's important. The other important thing to recognize about orbitals is that the first S is the 1S. The first P is the 2P. Okay? There is no 1P. The first D is the 3D. There is no 1D or 2D. And I'll remind you about that in just a second, but it's kind of important to recognize. Now, again, your S orbital, spherical orbitals, P orbitals are those kind of, dumbbell figure 8 shaped orbitals. We know that there's only, one amount here. There'd be 1S, there'd be 3 in the P, there's 5 in the D, and 7. So there's 1, 3, 5, 7 in the SPDF respectively. Now that's the amount of orbitals. Whether it's the 1S or the 3S, there's still 1. If it's the 3D or the 5D, there's still 5. There's still 5 orbitals. Now, what we're going to represent and how we're going to represent those orbitals are with dashes. So if there's 1S, it would just be 1 dash, 1 orbital. 3, 1, 2, 3 for the P. 5 in the D, so 5 dashes, and 7 in the, 1, 2, 3, 4, 5, 6, 7. 7 in the S. So the representation orbitals with dashes. You may see it with little boxes, but either way, it's just a representation. Now, if I fill these with electrons, knowing that an electron can pair up, the Pauli exclusion principle says it can pair up in these orbitals, but they must have opposite spins. That's what these arrows represent. Represent electrons and also opposite spins is what the up or down represents. Same thing in the P. We could have 1, 2, 3, 4, 5, 6. So there are 6 electrons in any P set of orbitals. Okay? So max electrons per orbital. Okay? 2 in the S. There would be 6 in the P. 10 in the D. And again, that's because there are 5 orbitals, and each with 2, maximum of 10. And of course, because there's 7, we could have a maximum of 14. Now I say maximum because obviously, just like in our analogy of cars in a parking lot, if we have a row that could fit 14 cars, but the first and second car are the only ones there, then there'd be 2. But you could have a maximum of 14. So this 2, 6, 10, 14 is going to show us something pretty cool right here when we talk about our periodic table. So let me go ahead and take a look at our periodic table with this max electrons. And again, I'm starting to now hopefully clear up some of the confusion maybe with this orbitals and electrons and all that stuff. Here's my periodic table. Okay? Notice that if I kind of block this periodic table into chunks, to me, that looks like a chunk that I could go together. This looks like a chunk that could go together. this section here certainly could be blocked together, and this section here as well. And so let's take a look at how wide each of these blocks are. 2 wide. 1, I'm not worried about this one. See how there's 2 across really? This helium oftentimes is viewed as being over here when we talk about blocks. If I put that helium there, then it's really nice and organized block-wise. 1, 2, 3, 4, 5, 6 here. So 6 wide here. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 wide in that block of the periodic table, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 wide here. These are specific blocks of the periodic table, and they're blocked by what orbital it is. So this is the S block. This one over here is our P block. This is our D block, and this is our F block. S, P, D, F. 2, 6, 10, 14. All right. I do want to mention something. I mean, the periodic table you're going to see in my room has lanthanum and actinum down here. Okay, La and AC right here. I like having them in the F block. Okay, and I like having 71 and 103 up in here. I still doesn't do anything for the width. It's still going to be 10 in the D and 14 in the F. I like having lanthanum and actinum in here because this is called the lanthanide series. This is called the actinide series. So it makes most sense to have them in there. But there's your blocks of the periodic table. You're now noticing, hopefully, that there's some patterns being created. The fact that there are 2, 6, 10, and 14 have a direct relationship with the fact that those are our orbitals. So 2, 6, 10, 14, and again, I can't stress enough, this would be the S block, the P block, the D block, and the F block down here.